afternoon, everyone. Today, I'll be talking about the activities that we have with respect to RISC-V within the Chips Joint Undertaking. I'll try to present you shortly our vision, the actions, and the challenges that we are facing with this. Before diving into the RISC-V stuff, I will make a short introduction of the Chips Joint Undertaking, because although there are a lot of, I was happy to see a lot of participants of our beneficiaries at this event, there are also quite some people who haven't heard enough about the joint undertaking, the Chips Joint Undertaking. So the Chips Joint Undertaking was established in September 2023 in an amendment to the Single Basic Act, which is with the main task to implement the first pillar of the European Chips Act. So the Chips Joint Undertaking is unique because it's a tripartite partnership combining the efforts of the European Commission, the participating states, as well as the European industries. European industries are represented in this partnership with three industrial associations, which are ANEAS, an industrial association dealing with nanoelectronics, APOS, an industrial association for smart system integration, and INSIGHT, which is an industrial association in the field of cyber-physical systems. So the CHIPS Act was signed in September last year. It was a result of indeed long and complex negotiations between the European institutions, but this was actually the birth date of the Chips Joint Undertaking. Well, in fact, the Chips Joint Undertaking is not something new. This is already the third generation of joint undertakings. We had the first one following the tripartite model established back into 2008. These were the ENIAC and Artemis joint undertakings, which were back then implementing the Framework Program 7 of the Commission. The second generation of joint undertakings was the Excel joint undertaking, which was active within the frame of the Horizon 2020 program. So the first two generations were actually implementing the so-called bottom-up approach. So they were following a strategic research and innovation agenda, which was defined by the European industry. Now we came to the third generation of joint undertakings, which initially was started as a key digital technologies joint undertaking, and it was active under Horizon Europe. But with the adoption of the CHIPS Act, actually the key digital technologies joint undertaking was renamed to the CHIPS Joint Undertaking, and it assumed to implement not only the budget of Horizon Europe, but also the Digital Europe program. So just at a glance, the investments that we are dealing with within the CHIPS Joint Undertaking for the entire period of the program between 2021 and 2027. There are 11 billion euros in total into the program, which with a contribution of roughly a bit more than 4 billion by the European Commission, about the same amount invested by the member states, the participating states, and in-kind contribution by the European industry in the order of 2.5 billion euro. So, as you see, we have quite a large portfolio, but also an important part of this portfolio is the processor design. The design of processors in Europe. So here we have several ambitions to be actually addressed and to be followed. First of all, we would like to support the development of balanced portfolio of processors within Europe, so that are to be at disposal of the European industry. The next important ambition we are pursuing is to approach processor design holistically. So not only on the hardware side, not only on the software side, but actually to address the entire design stack of the processor. And then also we have the ambition to cover the entire value chain from software applications down to silicon. We also are open to act in cooperation with other initiatives of the European Union, with other programs. And our ultimate ambition is actually to secure European technological sovereignty and reliability in processor supply chains. So now the question comes, which is the processor architecture that would serve those ambitions? And the fact that I'm here suggests what the answer is. This is actually RISC-V. But how did we reach that, that conclusion, that RISC-V is a good candidate to meet our ambitions? The European Commission, in cooperation with the back then key digital technologies joint undertaking, has set up a working group on open source hardware and software, which came up with a report which is publicly available. You can download it from the websites of the European Commission. So this working group came up with a recommendation and a roadmap for European sovereignty in open source hardware, software, and RISC-V technologies. So, in a nutshell, what did this group do? They made a SWOT analysis, so they recommend us to maximize the strengths and the opportunities that the European industry has into the field of processor design, and to resolve the weaknesses and threats. The ultimate goal is that Europe must develop the RISC-V supply chain that should support autonomy in critical market sectors and to reduce our dependency on other parts of the world in the global economy. What does the market, in particular in the cyber physical systems nowadays, look like? Actually, we are evidencing the dominance of the ARM cores, RISC-V still having a marginal role on that market. The ambition is clearly not to replace ARM, but just to provide a viable solution to the European industry, and having RISC-V as a really good alternative that can provide industry-grade solutions and just to healthy compete with ARM in different sectors. So, what would be the approach suggested by the working group? We start in programs like the Chips JU, but also other funding programs of the European Commission, so that we start with R&D and we built an open source IP repository. Next step would be the first industrial deployment that will be in which we will gradually start using open source IPs for application component design, but also we start gradually the industrialization of those IPs already, of these open source IPs. The final stage in this roadmap would be the exploitation stage, where we expect to have a successful exit to the markets. So, how do we, within the Chips JU, support these ambitions and this roadmap? In a sense, after we have this roadmap, the governing board of the Chips JU makes a critical reading and critical review of the roadmap and incorporates these suggestions into the multi-annual working program of the joint undertaking. In this working program, there are basically two approaches that we take. One is the traditional bottom-up approach, which uses the so-called strategic research and innovation agenda defined by the industry to make developments related to RISC-V. The other approach is going into the opposite direction, so it's a top-down approach, where we have focused thematic calls for proposals. In both approaches, we have some key guiding principles which are applied to our activities. First, as I mentioned, we assume a holistic still architecture-centric approach, where we have development of hardware and software IPs, but also with the appropriate EDA tool support, as well as software development tool support. Another principle is that we should ensure compatibility with the RISC-V architecture, and not only at the ISA level, but also at register level, at programming models, etc. We can boast with existing assets already within the EU regarding RISC-V development, so this is also important to build on these existing assets already. Our actions focus on gaps and needs which are identified by industry. I would like to remind you that we are an industry-driven program. So industry defines mainly the agenda of our program. We also encourage complementarity and healthy competitions about different solutions for the IPs and for the tools. And we allowed smart interoperability between open source and proprietary IPs and tools. So open source is not a religious term in here, right? We also appeal for healthy coexistence of both the proprietary and open source. Another principle of ours is to promote successful open source business models, however. So because we have the understanding that open source does not mean for free. There are many good examples of really viable business solutions based on open source. And last but not least, we target industry-grade RISC-V developments within our actions. So let me say a few words about the bottom-up approach that we have first. As I mentioned, we have a strategic document, an important multi-annual strategic document called ECS, or Electronic Components and Systems Strategic Research and Innovation Agenda. It is a very thorough document with very wide scope, and it is organized in chapters which basically include foundational technology layers. It includes cross-sectional technologies and also includes key application areas. To the left of this slide, you see the traditional view of the classical computer design stack. We have the computer architecture in the middle, which is basically the interface between software and hardware. And this area actually covers within its chapters all the identified layers for the computer design identified here. From software applications, via compilers, operating systems, middleware, through the architecture down to microarchitecture and actual hardware realization. We also have, of course, adequate tool support for all these design layers. So this is one way we approach from bottom up the problems, the design problems with RISC-V. Well, we have another approach, which is top-down, and it is promoted via so-called focus topics. The focus topics are in general complementing the bottom-up approach of the SRIA. They are initiated by either of the three main stakeholders of the Chips Joint Undertaking, and they address strategically important areas for Europe. RISC-V apparently being one of those. They are all these proposals for focus topics are based on roadmaps, which are also prepared by dedicated working groups. So this is our approach. We have a couple of focus topics. I will just talk here about the RISC-V related topics. So far, we have had 3 calls on this on RISC-V. The first one in 2021, which was basically saying picking up the low-hanging fruits. So this was the focus topic 1, and it was aiming at development of general purpose processor building blocks for RISC-V. So this is the Tristan project. I was very happy and delighted to see many times this project has been referenced here, also within the talks, but also within the booths in the audience. The sister project of Tristan, which was awarded in Call 2022, was the Isolde project. There, the objective is more to go towards customization of the cores, but with heavy reuse of already developed IPs from the Tristan. And the third focus topic, which is currently under evaluation, is actually more specialized, and it targets high-performance RISC-V automotive processors, which are supporting the software-defined vehicle paradigm. This topic is under evaluation, as I have mentioned. So this is a sketch of our top-down approach. You can see the first 2 projects already, Tristan and Isolde, which are implemented as linked actions. That means that there is a formal link between these 2 projects, and they are contributed to the common open source IP repository for RISC-V. The plan is also the new project, whichever it is when it is awarded, also to be implemented as a linked action to the preceding ones, so that we have one common IP repository that is that these actions contribute to. There is another type of outcome, though, and this is an expected industrialization of the results. So that industrialization naturally would consist, of course, of open source IPs, but we may also include certain proprietary IPs. So we have basically 2 types of results from our projects. We refer to them as horizontal, and these are basically the results which are shared and reusable into the RISC-V IP repository. But we also have domain-specific cores ready for industrializations that may be either shared, but they can also be proprietary. This is another view of how we see the evolution of this common repository. As you can see, we are expecting that each of the actions in the project, in the calls and projects to come, will contribute to this repository, which will mainly consist of reference system, software tools, specialized libraries, and foundational libraries. All of them serving either for general purpose processors or for application-specific processors. Again, 2 types of projects results are expected. Open source RISC-V IP repository available to everyone, but also certain industrialization efforts are expected to pick up around the year 2025, when the first really close to industry grade results from project Tristan will start appearing. So, at a glance, what was our approach? We had prior work within the Chips Joint Undertaking, where we had some RISC-V developments, but they were mainly as parts of projects, as tasks, as work packages, not really dedicated RISC-V projects. Then with the launch of the KDT, we started building our strategy. So we first initiated the working group, which developed the roadmap, proposed the roadmap for the open source hardware on RISC-V. Then we updated the SRIA with RISC-V by 2022, 2023. That is to support our bottom-up approach. And finally, we had established a new working group which will detail the roadmap for the automotive RISC-V processors development in particular. Currently, we're in the strategy implementation phase. So far, for the first 2 calls, because they were granted already, the 2 projects were already granted, The total cost is in the order of 95 million euro, 27 of which are Horizon Europe funding, matched with national funding of 25 million, and private in-kind contribution of 43 million. The current, the proposals under evaluation, currently under evaluation, are competing for Horizon Europe funding of 20 million euro. About the same amount will be allocated by the national funding authorities, and the expected cost would be 60 to 80 million euro. So far so good. There are still, however, a lot of remaining challenges. So this is a non-exhaustive list of some on which we will keep on working. The first one is the tool support both at the hardware and the software level, design levels. So this includes EDA tools, but also compilers. And I was happy to hear a lot of nice ideas, a lot of nice proposals already in the talks, in the course of these 2 days that I have been happy to attend here. Then the second challenge would be the support of the system level hardware design. And that is, we need to come up with families of RISC-V compatible components, but accelerators, peripherals, network, memory, subsystems. So the entire infrastructure that goes around the RISC-V. This is still important for the real industrial take-up of the RISC-V. So third challenge would be a system-level software support that goes towards operating systems, real-time operating system in particular, and middleware to support those. A fourth challenge is, of course, silicon realization. We aim at tape-outs, but also chiplets. It's also important to have availability of new PDKs, and I would like to mention the new technologies that also Chips Joint Undertaking is supporting through the so-called pilot lines. I will just not have time to talk about them, but these are also promising technology realization platforms, which are good candidates for RISC-V realizations. And last but not least, a really big challenge is towards the European industry. Will the European big industry really recognize RISC-V and take it up as a viable platform for economy significant scale? This is really a challenge to be considered. As I mentioned in the beginning, the scope of the activities of Chips JU is far more than processor design. Nevertheless, we are trying to put together and to have certain synergy between our activities. And just to mention a few here, we have also a focus topic on software-defined vehicle. And the work of that particular working group, together with the working group on RISC-V, actually resulted into the roadmap for automotive RISC-V processors. We also have focus topics on Edge AI system, where we have a lot of RISC-V-based solutions, and we also have a lot of actions in the general bottom-up approach in the S-area, where we have different applications, just to name a few: medical networking, safety critical, in particular cyber-physical systems, but also we have a lot of applications, a lot of actions in the field of process technologies, which also consider RISC-V in their core. It's here the place to inform you also about the upcoming design platform initiative, which will provide, among others, also tools and tool chains for holistic RISC-V chip design. And we also have the pilot line initiatives, which are dealing with advanced cutting-edge silicon semiconductor technologies for the next generation of chips. Our ambition is also, in the coming days, in the coming years, most likely, to use the developments there as platforms for realization of RISC-V chips. We the Chips Joint Undertaking are also open for collaboration with other activities, with other programs by the European Commission in particular. And here I think it is worth mentioning EuroHPC, I would say our sister joint undertaking, so where they also, as you know, have a high-end RISC-V for supercomputing applications initiative. In particular, we could identify certain overlaps in our activities there. I would like just to mention that there are potentials for IP reuse via shared libraries and repositories, but I would also like to consider common design tools that may be used in by both initiatives after certain adjustments, of course. So that leads me to the conclusion of my talk. I try to demonstrate the ambition of the Chips JU to be a key driver at the political level to establish RISC-V as an industry standard in the European Union. So we are doing our best in that direction. There has been an excellent base of prior RISC-V developments before we start thinking more strategically in that direction. And we have already within our community sufficient design skills and critical mass of those skills which can take us to the next level. I have shown you the Chips Joint Undertaking's two approaches, top-down and bottom-up, which work together. They complement each other to support linked actions at all levels of the RISC-V design stack. That is including system integration, but also architecture, microarchitecture, tape-outs, and also software design tools, so not to forget the software. And we are open for synergies with other EU programs. Our ultimate vision is to support the development of balanced portfolio of RISC-V families and also widely accessible IP repository that should cover the entire value, but also the supply chain for more secure European sovereignty. And that concludes my talk. So I'll be happy to take some questions.
Thank you very much. It was a very interesting keynote. We have time for a quick question before the panel, if there's any. There.
Hi, that sounds very exciting. So I'm a European citizen. I'm a software engineer. How can I get involved?
Well, we are a very open program. We organize actually the industrial associations organize their brokerage events. We have also our event. This year it's called FX. So you just come, you present yourself, you get into the crowd, you listen for ideas, and you join certain consortia that are being formed at that event. So that is the straightforward way of joining a proposal which eventually would become a funded action by our program. Maybe I should have added our website, but it's easy to find it, and there all these events are well communicated, and it's open participation. Yeah.
What I want to ask you is, in many cases, when all these programs from the European Union and the European Commission, when you're looking at all these different funding that has been done for, mostly public initiatives, there are certain timelines, and then, for example, you have a 2-year project, a 3-year project, and how are you ensuring like continuity?
Okay, thank you for this question. Actually, I should have emphasized maybe a bit more on one phrase in my slide. It's linked actions. This is the way we currently implement our focus topics. So each project which is awarded a grant is obliged to sign formal contract with the other already ongoing projects, which is an implementation as linked actions. And in this formal agreement, they have to, they commit to provide, to share IPs. In that respect, the continuity is, at least regarding the IPs, IP use and the IP repository update is guaranteed. It is not ideal, right? But within the instruments we have, this is one possible solution. Of course, as an industry-driven program, we don't want to have our actions the results of our actions die immediately after the end of the project. So this is one way of ensuring this continuity. Of course, we also count on the take-up by industry, because as you have seen, we don't pay 100%. So we are a program which is targeting a higher technology readiness levels, and the fact that industry also puts their own funding in our actions also is a sort of guarantee that there will be viable take-up of our results.
So